Hello and welcome everybody. Thank you for joining this Neo4j Live Type and Refactoring Safety and User-Defined Procedures. I'm looking very much forward to this session today, and I'm very happy to have Elena and Jens Deininger join me today. So hello, Elena and Jens. Well, it's evening here, so good evening here to you both. Thank you for joining.
Thank you.
Thanks.
Very, very cool. Thank you for making it. Thank you everybody for watching live. Today, as usual, if you have questions, if anything is unclear, if anything needs a little bit more explanation, then feel free to use the chat window at any time and type in your question, remarks, comments. Also, if you just like it, also good to hear. So do that, interact with us during this live, but obviously afterwards, towards the end, you will also find contact details for both Jens and Elena in the future if you have more questions about it. So this is no problem to reach out afterwards as well. This session is not really a follow-up to notes, but kind of is a follow-up to notes. Elena presented a couple of weeks ago at Notes a very interesting session, which was one of the most watched and most liked sessions during Notes. I think it's no secret to say here that this got out of from a score from going from 1 to 5. This got a 4.6, almost 4.57 to be precise. So this is a very high rated session. She sets a little bit of well, it's not really a foundation. How would you say, Elena? Is it
it's like a reasoning of why you should use user-defined procedures at all? Like, what is it and why should you use them?
Yeah. So if you haven't watched that, if that is something you'd like to know about, then the video link to the recording from Notes is in the YouTube description, so you can click on that and watch it. Obviously not now, but afterwards. Or if you watch it on YouTube, maybe you pause this one and watch the other one first. It's a lightning talk, so it's 15 minutes, I think. So it's quick, so you can start with that, but no need. Now, if you watch it live right now, you don't have to watch it as a prerequisite. This is all fine for you to explore today and to listen to what Elena and Jens are saying. So yeah, I'll post a link to all the Notes videos in chat again. So just in case if you missed Notes and you want to know more about what's going on, then all the videos, all the sessions are available there in a YouTube playlist, so you can explore that at any time as you like. But now we talk about user-defined procedures, and I'll hand it over to Elena and Jens.
All right. Yeah. Thanks. So I'm gonna share my screen quickly. All right.
There it is.
Cool. Right. Yeah. Hi, everyone. Thanks very much for joining. So we're going to talk about type and refactoring safety and user-defined procedures today, just as Alex already said. Thank you very much for having us. And before we really dive into the topic, we'd like to introduce ourselves first a bit. So we're Elena and Jens, and I'm going to just talk a bit about me. So I'm a specialist digital engineering right now. I work at a company called RLE, which is an automotive engineering services provider. And I'm also a Neo4j ninja of the first hour, basically. So how did I get to graphs and get to this point, basically? So at the beginning, when I started my job, I did a POC and I had to implement a huge graph traversal. So I had a huge graph and I wanted to go from one node to the other. And well, I was just getting started with Neo4j and I just did that with Cypher. So I wrote some Cypher queries, which I had in a loop, basically, which then traversed the graph. And with the growing graph, they were becoming very, very slow. So at some point, I realized, well, okay, I might need something else. And that's where I discovered user-defined procedures. And so I set sail to translate all my Cypher code into user-defined procedure code. And it worked great. So it reduced the duration of the whole calculation from about 5 minutes to 3 seconds. So that's a huge reduction. It was great, but actually, despite of doing test-driven development, so we were really actually writing tons of tests for every single procedure that we were writing, and they were all passing. But still, we had a lot of problems in integration testing, because then in the huge database, some properties were missing, or some nodes were connected differently, or there was something wrong with the graph which we couldn't grasp in the test-driven development in the beginning. That's actually where I met Jens last year, in the beginning of last year. And yeah, I'm going to give the word to Jens to introduce himself as well.
Yeah, I'm also a software developer. My experience is mostly in C#. I've been working with nothing but C# for 15 years. I was entirely new to graphs and graph DBs, but I already came with a strong liking for reflection and metaprogramming. And crucially, I had already to work, or the pleasure or misfortune to work with my own code that I've written 10 plus years ago. And if you ever looked at your own code that is that old, you get it's a scary experience to ask yourself, what the fuck did the author want to tell me with that? So I have experience in what projects like, if they're around for a long time and you've been fiddling here and there and everywhere. And that's of course more or less exactly what I found with the user-defined procedures. And I started thinking, how do we get this to be more stable? How do we get this some basic type safety, some basic refactoring safety? How do we stop looking for days or hours on end for every single stupid little bug? And that's why I came up with this descriptor framework.
So, and yeah, just as Jens already said, so we met beginning of last year, and basically worked together on a solution for better code quality to solve this problem of user-defined procedures that we had, which was a lot of effort in integration testing. And this is what we want to tell today. All right, so what are we going to talk about? So basically, in the beginning, I just want to introduce the topic. So what are user-defined procedures, and where are the problems if you just use them out of the box? Well, you'll see there's going to be some typical problems. I'm going to present some usual solutions for parts of these problems. And then at the end, we're going to present the solution that we came up with, show some code and show how it works. And we're happy to answer any questions you have on the way. So keep posting. So let me just directly get started. So what are user-defined procedures? So if you go to the Neo4j documentation, you'll find the info on that in the how to extend Cypher part area here. And if we just read that quickly, well, we see that Cypher is very powerful and you can do a lot of stuff with that. But there are cases where you just need more than just Cypher, like additional graph algorithms, as it says here, or some more stuff. And then you can extend Cypher with user-defined procedures and functions. And actually, there's three kinds of objects you can use. So there are user-defined functions, user-defined aggregation functions, and user-defined procedures. And just so I'm not going to go into very much detail, but just to give you a very rough overview what that is. So the user-defined functions, they are read-only. So you cannot modify the graph when implementing a user-defined function. And it maintains cardinality. So it means if you have a node and pass it to the function, you get one result back. If you pass 4 nodes, you get 4 results back. So for every node, there's something going on. In contrast to that, there's the user-defined aggregation function. So they're also read-only. They're quite similar to the UDFs, but they reduce the cardinality to 1. So if you put in 4 nodes, you get just 1 result for that. So maybe you want to count the nodes, like count is a very good aggregation function, right? So it just reduces 4 into one number, which is 4. And then there's the user-defined procedures. They're much more powerful than the others. They're read and write. And they're not bound to any cardinality. So you can put in whatever you want and you can get out whatever you want. So the output can be a stream of basically anything. So you can show whatever you want on the Neo4j browser. All right. And actually, that's not that exotic. So Neo4j also has procedures, and you all probably know them. So APOC and GDS are plugins that you can use in Neo4j. And these are also basically user-defined procedures, just not ones written by someone like me, but written by Neo4j. Okay, and as Alex already said, I did a very short notes talk on the topic of why you should use user-defined procedures. That's not what we're going to cover today, because today we're going to say, okay, we are using user-defined procedures, and there's problems this and this popping up if you do. All right. So in the beginning of the year, I think around April time frame this year, I wanted to know more about the usage of user-defined procedures in the community. So I wanted to know whether people are using that or whether they're not, and if they are, if they're using some kind of type safety within that, maybe like where we have invented something that was already there before, or there's better solutions to do that. So I conducted a little survey in the Neo4j Ninja community, and I had 16 people who participated. And as you see here, like they were mostly people who have a lot of, like more than 2 years experience in Neo4j already, or at least like a year. And I asked them, what kind of projects are you working on? Is that like very basic? Is that POC, so experimental, or are you working on more serious projects? And we see that most of the people who answered the questionnaire said that they're working on very serious projects. And then I basically asked, are you using UDPs or not? And this was the solution. So 11 out of 16 said they're not using UDPs, and 5 people were using UDPs. And then I had another question saying, well, if you use UDPs, are you using something to ensure type safety? And the answer was no. So no one thought about type safety. And then I also asked the question, like, why aren't you using UDPs? There should be a reason for that. And the most frequent answers for that were, well, Cypher solves all my problems. And yeah, that's great. So Cypher is very powerful. So if you're not needing to use UDPs, then you shouldn't, of course. Well, it's just more work. And if you can be happy with Cypher, that's great. But as I said, it didn't work for us because it took like 5 minutes to traverse my huge graph. I needed an algorithm. So Cypher wasn't a solution for me. 3 people said that they have never heard about UDPs. I think, well, there's just not much talk about it in the community actually, because just Cypher is the most prominent thing and people are getting started with Cypher. It's easy to get into. Of course, writing user-defined procedures is more hard because you have to do that in Java. And of course, you have to be a programmer before that, or you have to know at least some Java, which is more of a hurdle than, of course, writing Cypher. And one other thing that people answered is that there's no way to deploy UDPs to Aura. And this is, of course, a very big drawback. Of course, you can deploy user-defined procedures if you host your own Neo4j database in the cloud, but you can't do that on Aura. And I talked to the developers of Aura a long time ago, and they said, well, that's probably not going to happen at all, or at least in the very far future, just because the security risks are too high if people could introduce their own procedures into Aura. And then in that same time frame, basically, I'd talked to a UDP expert from Neo4j, basically asking the same question, like, what about type safety and user-defined procedures? And he said, well, even he is not using UDPs much in client projects. So basically, since Cypher is so powerful, people should use Cypher, and he's also using Cypher in this project. So he just employs UDPs here and there where he needs them, but he doesn't do that for a complete project or anything. Okay, so let's sum up. If you ask the community, are you using UDPs or not? Well, the majority is going to say no, not using that. Cypher is sufficient, and only a small fraction of people are using UDPs. And from these people, most people are just using UDPs here and there. So maybe there's some procedure that has some 100 lines, and then that's it. And only a few of them are really having huge UDP projects. And so this is what we're going to talk about today. So that's quite niche, I know. But this is actually where type and refactor safety starts playing a role, right? If you have a huge project, you have, and what do I mean by huge project? I mean like several distinct procedures on the same graph. So you have the same schema and you have a lot of procedures going through the graph. You have a lot of files, a lot of code lines, and the procedures are very complex. So not just 100 lines, but maybe 500. Then this is where you start to think, well, I need some type safety to do my coding. So for the rest of the
Elena, if you just a thought came to my mind is if you are using a lot of APOC procedures, could this also be helpful in this way to have type and safety through a user-defined procedure, or is that not a use case you would see?
No, not at all. So you mean if you're using APOC from Cypher, right? If you No, not really. I mean, the APOC procedures, they're very general, right? They don't care what kind of graph you have. like this type safety really comes into the game when it's about you have a car node and you have a person node and you want to do logic on these.
Okay.
And your procedures are specific to car nodes and there being a specific relationship between cars and persons. So this is where this type safety comes in. And of course, all the APOC and all the GDS procedures, they're not type, they're not made for a certain business logic, but they're very general, right?
Divergent, yes.
That's why also Neo4j itself didn't need any type safety, because these procedures are just not made for a specific use case.
Yeah, that makes sense.
Yeah, but I think we're going to see that later in our example where this comes into the game. So for the rest of the session, please assume that you're having a huge UDP project, and don't think about, I'm just having like 100 lines of code and this is all too much what you're showing. So please assume that you have a huge UDP project which also makes sense for your case. And also we're going to show very easy examples, and you're going to probably shout out, well, you can do that in Cypher. Why do you put that into a user-defined procedure? Yes, we know we can also do that with Cypher, but if we wanted, like if we were showing 1,000 lines of code with some complex optimization algorithm, then you wouldn't be able to follow, right? So please don't say you can do that with Cypher. That we know that. We just wanted to show easy examples. And yeah, all the code that we show is available on GitHub. The links are available in the at the bottom of this presentation, which is also already online in the YouTube link. All right, so now let's get a bit of practical hands-on stuff. I'm gonna quickly switch to the Neo4j browser and gonna let Jens introduce our topic.
Right, sort of the small little example, slightly humorous, that we thought about was King Arthur and his Knights of the Round Table. They want to get the Holy Grail, and they want to do this fast and efficient. And so Arthur asks Merlin for help. Merlin, being a modern wizard, conjures up this graph database. So we have a very simple database. We have quests, we have knights, and we have items. And the knights can go on quests. They use items for these quests because some of these quests require certain items. And of course, a quest has preceding quests. Like, you know how this works. You can't just go get the Holy Grail. You have to pass through the Valley of Fire first, and you don't know the way to the Valley of Fire. It's just the Swamp Witch who knows the way. So you ask her, and she's not going to help you because she wants 3 magic beans. So you have to go kill the giant. And she wants a love potion for her cat because the cat doesn't like the new dry food that she supplies. And you get that love potion or love spell from the wood nymph, and she has a problem with the poachers, so you have to get rid of them. You know how this works. Like, you have a lot of preceding quests, you have to do all that. And this is if you show the full database, also not that large. I mean, you can, I guess, see this is a very small example. You can do all of that in Cypher. But if you imagine this being larger, like there's not 5 quests, but 100. And of course, the model isn't sufficient. You would have some kind of level up. I mean, if you have heroes, you want some level up. We all like level ups. And then some quests will yield new items. You can use those on other items. And then the quests have a duration. So basically, if you imagine this to be a proper model for the usual MMORPG, and you want to find some optimum path for how to do a speed run, then I guess you can imagine that to do that kind of optimization, there's absolutely no way you can do it in Cypher, because you need all the data anyway. So one thing to do would be to pull the whole graph, map every bit of information onto some high-level objects in Java or some other high-level programming language, run your optimization, and then you have an answer. But of course, transactions are expensive. And if you pull the whole graph, that's kind of silly to pull absolutely everything. And of course, these high-level objects in a high-level programming language, they already exist. They exist right there in the database, and you can access them with user-defined procedures. So you don't have to actually pull anything. You can write a user-defined procedure that does the full optimization right there on the database. And for a sample for some of these user-defined features, how you user-defined procedures, how you would normally write them, Elena is going to show 2 examples, which knight is on a quest and a procedure that sets the usage of an item to a new knight.
All right. Yeah. So just since that, let's directly jump into the functions and procedures. So the first one we want to show is having a knight node and returning the quest that the knight is on. And of course, again, yeah, you can do that with Cypher, I know. But we just wanted to have a very easy function to show. So I implemented a user-defined function. And if you remember from the slide, well, this maintains cardinality. So for every input that you have, you get one result back. So the function is called getQuest, and you supply a knight node into that. So let's quickly just look at what that gives me. So we have Sir Lancelot and Sir Gawain being busy visiting the Swamp Witch, and Sir Percival kills the ogre. So Sir Gerand is not having a task right now, and this is what we see here in the graph, right? So there's no magic involved here. So Sir Gawain and Sir Lancelot are visiting the Swamp Witch. Here's Sir Percival killing the ogre, and somewhere we have Sir Geraint not doing anything right now. Okay, let's look at the code that does that. So we're quickly going to show the function that produces this output. For that, as I said, user-defined procedures and functions are written in Java, just a very little Java code snippet that I want to show here. And this is this one here. So as we already, which is called getQuest, and it receives a knight node into it. And well, what do we need to do if we want to know the quest that it's involved, the knight is involved in? Well, we just can use the get relationships
Can you zoom in a
method
little
of
bit,
the
Elena?
node. Yeah, of
Just
course.
a little bit. Yeah. Thank you.
Better?
Perfect. Yeah, that's much better. Cool. Thank you.
So we use the get method on the knight, right, on this node that we received. And we tell them, okay, there's an outgoing edge, which is of the type is involved in. And then I get an iterable on the relationships. These is involved in relationships of this knight node that I provided. And then what I don't want, so I have the relationships, but I don't want the relationships. I want to have the end node, right? I want to know the quest which they're involved in. So basically, I need to iterate over the relations normally, but in this case, I know that a knight can only be involved in one quest. So I just have a look whether there's any in there, and if there is, well, I just pull the end node of this relationship and have a quest, and then I can use the get property method on this quest node, and then say, okay, I want to have the name property back, and I can just return that, and I return none if there's nothing going on. So if the knight is not involved in anything. So we saw the execution of that already in Neo4j. I don't need to show that again. But so what kind of problems can we have with this little snippet of code? Well, first of all, I think I got a knight node, so a node with a label knight. The user can give me anything, right? They can provide any node to this function, and then he thinks it will function, but it won't actually, because another node will probably not have the is involved in relationships which are outgoing of it, right? So we already have a schema in mind which we're using these methods on. So what I would need to do first actually is to see whether this is actually a knight node or not, right? So I would have to check whether it has a knight label, and if not, then maybe throw an exception. Okay, then I iterate over the is involved in relationships. All right, and then I don't know if anything came back, right? And I don't know if the quest that I get here, for example, if that's actually a quest node. Maybe that's another type of node. So actually, again, I need to check whether the node that I got back has the quest label. And then I want to fetch the property name. But what if this node that I got back, which has the quest label, doesn't have a name property? Or what if it's not a string? So I'm saying here that I want to cast it to string, but maybe I can't just because it's not a string. So there are a lot of things that I didn't check here, where I just assumed everything's fine. And we can look at an interesting example. So what if we add some node here into our graph, which is a queen node. So we add Queen Guinevere and create a relationship from Sir Gawain using the is involved in edge, right? So I'm just quickly going to do that. And then I'm going to just call my getQuest method again on all the knights. And well, it says now that Sir Gawain is not visiting the Swamp Witch anymore, but is involved with Queen Guinevere. Well, that's not what I wanted. Queen Guinevere is not a quest node, right? But of course, my stupid or my not checked function doesn't know that and just does what I programmed it to do. Okay, so what could you do? We try to show that here in the next method that we wrote. You could just just check everything, right? You're not trusting the schema anymore. So we're first checking whether the knight, this node that we get from the user, actually has the knight label. Okay, then we're getting the relationships. Then we're fetching the end nodes of these relationships. And if there's more than one of these nodes, then we already throw an exception again that the knight is involved in more than one node. And if it's not one, then maybe we check again whether the quest node actually has the label quest. And if that's not the case, then we again throw an exception. And you get the point, right? You can just check and check and check stuff, but that's not what I want to do. Like this is like much more code than the few lines that I had before. This is not what you want, but this is actually what you would need. Or if maybe you start thinking this is what you need in order to make this all safe, right? And actually, if I now use this method, the getQuest handle errors on the my new graph, so this is this one here, right? Then I actually get this exception as expected. The knight is involved in more than one node, right? Okay, so now I already know, at least know that there's something wrong here. Okay, and now let me show another piece of code, which is a procedure this time, which shows a bit of different problems that we can get when working with user-defined procedures. So I'm gonna switch to the procedures that we wrote. And as Jens, from the logic, it's not difficult. So basically, we're providing a knight and some kind of item to this procedure, and we want to know whether the knight could use this item. And maybe so our items have different types, like a weapon or an armor or a shield. And if you're already using two weapons, maybe you can't use a third weapon. Or if you're already wearing armor, then you can't use a new armor. You first have to get rid of the first one, right? And this is just a procedure that does that. Here again, we're just fetching some properties like the knight name first and the type of the item that we got. And again, we say it's a string. Okay. And now we first have to fetch all the items that the knight is using, right? Because we have to see whether maybe this item is already in there, or we have to also see which kinds of items he's using in order to be able to say whether the new usage is possible or not. So again, we're using the get relationships. This time we're going to use the users relationship. And again, we need to iterate through all the users relationships. We need to fetch all the end nodes of these users relationships. And then we can actually add the item, which is again a node type here, into some, in this case, it's a hash set or set. We can just add the item. Okay. And then I don't want to go into much more detail here. Basically, if the new item is already within the items, then I give a message saying, well, this item is already in use. It's not new, right? Nothing happened. And then I count which kinds of items the knight has. And then I have a bigger switch case here where I again use the item type and see whether that's an armor, where, well, it can't only use, the knight can only use the armor if it doesn't have one already. And so if it doesn't have one already, then we can create a new relationship, right? This usage is successful. So we create a relationship from the knight to the new item with the users type. And in our case, the users relationships, they have a property named since. So we just put some value on this since property. And what we have to do again, if we, like in this case, there's the weapon usage is also successful. So we have to do that again, right? We have to create a relationship and we have to set the property and so on and so on. And that's basically what this method is doing. So what you should pay attention to, what we have here is strings, right? And maybe you wouldn't want to have strings in a switch case. So maybe you want to do a switch case over proper enums, which you can't do here, of course, because you just get the type as a string from the database back. And also, you would want to be sure to never forget this property, right? If you forget it and then your graph gets invalid because, well, if you then want to rely on that property coming back to you and it's not there, that's not really good. Of course, you could now also create a new class where you just put this method in where you just have this create method so that you only have to write it once, which is already a bit better, but it's still not as good as what we wanted to do with all this. So let me just sum it up a bit, what we just saw until now. Or maybe let me first show you how this use item procedure works. So just have a quick 2 examples. So I have a knight here, Sir Lancelot, and I want to give him the vengeful mace of smiting. So I'm calling, so user-defined procedures always have to be called with this call word. But despite of that, that's basically the same as we saw before. You just have to give the namespace of the procedure, and then you can return stuff. So let's see whether that works. And in this case, it doesn't work because Sir Lancelot is already using 2 weapons, and he can't use a 3rd weapon. Okay, well, nothing happened. But what I can try to give that to Sir Gawain, same item, and in this case, well, it's working. Now Sir Gawain is now using the vengeful mace of smiting. So, and also the relationship was created in the database. All right, let's go back to our slides because I want to sum up what we saw now, what the problems can be. And I want to start with a quote from Michael Simons, who's a software engineer of Neo4j. He posted a blog, I think a year ago, where he said, well, basically you can't have no schema. There will always be a schema. And in this case, we have the knights, we have the items, and we have the quests. And of course, we can write anything into our schema-less database, which is Neo4j. But in this case, we have a schema, right? And what we would want to do is validate it, right? We want to see whether our graph actually is what we think it is. And if it's not, then we want to see problems, like we want to see the nodes that don't match our schema. And then there's type safety. So we saw in my procedures and functions that I'm, for example, fetching nodes, but I don't actually know if that's the nodes that I wanted, whether they have the labels and the properties. When I'm fetching properties, I don't know whether they exist and which type they have. So they could be any type, right? Because there's no one stopping you from writing anything into the database what you want. And then I'm iterating from one node to another. I want to use the right relationships. So am I using it right? Like, is that the relationship that I'm looking for? I want to end up at the right node. So again, when I'm fetching this end node, is it node that I'm looking for or is it not? How can I be sure? And maybe sometimes I know the cardinality of the results. So maybe I know in this case that the knight can only be involved in one quest at a time. So I want to get the single quest that he's involved in. But as we saw with the get quest function, well, if there's another one, yeah, what happens? Like in this case, it was the queen. So difficult times. And of course, when I create nodes and relationships, I want to create them right. I want to put the I want to put the right label on, or labels. Maybe nodes have several labels, and I want to write all the properties to the node that this node needs in order to be a proper node kind, right? We saw that the user's relationship needs a since in our schema. So how do I do that while not going mental with writing all these exceptions and so on? And I want to show quickly, or I want to quickly mention how you would normally do that. Well, this is not a new problem, of course, right? It's not what we encountered first. So if you want to do validation in Neo4j, then you can start with creating constraints. So you can constrain, for example, that a property needs to exist. And whenever you create a node, then you also need to create these properties, or else this node can't be created. You can also set property type constraints. So you can say, okay, this property name has to be a string. And if you don't put in a string, then this can't be created. You can create key constraints where you can say, okay, certain combinations need to be there of properties on nodes and relationships. But you can go only to a certain extent with constraints, right? You can't say that there needs to be exactly one node at the end of a certain relationship, or like there needs to be only one relationship of that kind for a node. What you can also do is use the shapes constraint language of the World Wide Web Consortium. So they created a kind of language where you can specify what kind of graph you're expecting, and then just test your Neo4j graph against that, which is cool. And then they can do a lot more already. What you can also do is use the graph schema introspector, and this is actually a project from Michael Simons. I think this was also one from this blog post that I had on the last slide. So this can also, you provide some config, and then also the introspector checks your graph against that schema. If we're talking type safety, well, probably OGM comes to your mind first. So if you're using Python, for example, you can use NeoModel. If you're using Java, you have Spring Data Neo4j. If you're using a JavaScript application, then you have GraphQL. So there are a lot of ways on how to do type safety on your graph. But these are not ways you can use in user-defined procedures. So these are ways you can use with a driver. So when you're outside of the database, you can access the database in a type-safe manner. But what we want to do is we want to stay inside the database because we have the node relationships and want to do a proper want to do good traversals of the graph within the graph, then we can't use them. There's also something called the Cipher DSL, which is a library which you can use to create type-safe cipher. And you can actually use that inside user-defined procedures as well. But this is also not what we want, right? If we have nodes and we want to iterate from one node to the other, then we can't just create cipher queries. That just kind of brings it all to ad absurdum, because the power of the user-defined procedures is not having to look for nodes, but being able to traverse from one node to the other. So I posted a lot of links here. If you want to read up on these things more, there's a lot out there. So as I said, these are not applicable to UDPs, and what we are actually presenting, or what we wanted, is one solution for validation and type safety. So just get it all together, like put it all into one, and benefit from all of it. And this is where I hand over to Jens, who had the great idea to do something about it.
Okay, thank you, Elena. I share my screen. Oh, yeah, oh, does it work? Oh yeah, now it works.
Here it goes.
So I first
can you click on the little hide button at the bottom of your screen, so that the little, yeah, exactly there. Oh, perfect. Yeah. Thank you.
Okay. First, I want to talk about the sort of general ideas that led me there, and then I present some code. So the general idea is heavily drawn from basic meta programming ideas. So I want to use abstract base classes and abstract repositories that do a lot of the heavy lifting. In my case, they do all of the heavy lifting. And that stuff relies heavily on reflection, on attributes, and on pretty complex code that hopefully you need to set up once, test it, and then can forget about it for all times. So especially I like these attributes. I think everybody likes attributes. You can encode so much functionality in these attributes, and they are so easy to read. So these are sort of basic ideas that I have. I want really complex base classes and then very simple actual classes. And to show some code, what we need to do, I want to have a class for every node kind and a descriptor class for every relationship kind. It's important to remember this is not a static class, but it might as well be one. There is just one item descriptor, and that item descriptor tells me everything I want to say about all item nodes. And there is one night descriptor, and then one users descriptor, and so on. And this is really short. You can see it has only 60 lines. And what I tell here is I derive from the node descriptor, and that class, of course, looks horrible. That is really long, and that is very complicated and does a lot of reflection magic. And what I basically say here is a node that the item descriptor describes needs the item label, obviously, and that needs to be identifying. So basically, this item descriptor knows, it checks all the identifying attributes, and it feels responsible for every node that has the item label. I will then state that I want a name property, and it has to be a string property. I also want a type, a property key called type, and that has to be of the kind item kind property, which is an enum which the database doesn't actually know. So that's what I want to say about the every item node. This item kind property is already some trick in there. Item kind is basically just a really simple enum, just a normal Java enum. I have these certain values that are defined once, and then I define the item kind property, which is a property descriptor. And that's all I need to do. I extend my property descriptor. That class is also highly abstract and does a lot of reflection magic. And all it really needs is, it needs the type that is used in the database, a string, and it needs my type that I actually want, the item kind. And all the conversion and all the checking is done under the hood by this item property. So in this item descriptor, I can state that the node types actually have a property with an item kind value. Under the hood, of course, it's just a string. I can also further specify that these item nodes stand in relations to other nodes, which is what I do here. I write in here that there are relations that it's related to. There are quests and there are users. And I can state that the quest relations, that's a 0 to many relation. An item can be involved in no quest or in any number of quests. And for the user, it can have no user if it's just sitting in the armory, or it can have one user, but it cannot have many more users. And that's what I write here. The rest of the code, this is just copy paste. You always have to state this. It needs to call this init labels and properties. And that method, you can imagine, is long and does a lot of reflection magic. And you need these two methods, the quest relations and the user relations. They are basically just self-initializing. They set the value for the quest relation. The reason why I cannot do this initialization in the constructor is because the quest nodes, or the nodes, know the relationships and they depend on that. And the relationships, they have a start and end node. So they know something about the other. So there's no way to initialize everything in one go. Something has to come first and then something has to be initialized later. That's why these must be sort of self-initializing. But once I have done that, I have said everything I want to say about the items, the label, the properties I expect, and the kind of relations they're involved in. And the relations, they also extend. This is the descriptor for the users relation. It extends from the relationship descriptor. It needs an identifying type. Every relation needs a type and it only has one. So it needs to have the relation type users. I wanted to validate that it does have this property since, with a property key since, and I want this to be a string property. And I also note that a user's descriptor has a start and a fixed end node. It needs to start from a node that is described by the night descriptor, and it needs to end on a node that is described by the item descriptor. This start and end node are optional. I could not specify any of those, then any end node will be acceptable. The benefit for that stuff is I can use something really simple like this one. I already defined that an item can have one user or no user. So I can have this really neat method that gives me a use the descriptor, call the base class node, pass the node relation 0, 1 to it, and pass the other node. And it will return an optional node. That's 0 and 1. And this base method here knows, because this is of the type 0, 1, the return type will be an optional node. I have the same method here for the quests. This one gives me all the quests. And because of the type of this node 0 relation, it knows that it will be a stream of nodes. Of course, under the hood here, a lot of the same stuff happens. It iterates over the relationship, gets the end nodes, fetches it, and returns the result. But this is a lot easier to use, and I save on all the iteration stuff. The user's descriptor, we can also already include this neat method here if we want to create a user's descriptor. If we want to create a use relationship, we supply the night node, the item node, and the property. And what it does is, first it does all the checking. First it checks whether this night node is actually a night node. So it calls the night descriptor. A night descriptor has an identifier, and we can check if the node matches that identifier. Same with the item node. And if either of those is wrong, I can throw an error because something is not right. Then I create the relationship and I set the property value on it. And to see this in action in comparison to the old functions, right, this is the first get quest function. And down here is the descriptor version. To make the comparison easier, we put them in separate files and use the differential view here. So what you see above here is we don't do the iterating. Here we have to iterate, and we have to remember it's an outgoing relationship, and that's the relationship we want. And this one, we just ask the night node descriptor to get the quests on this night. So we don't have to remember, is the outgoing, is it involved in? It might have been the other way around. I mean, this one is probably easy to remember, but you could screw this up. And we also already know we get 0 or 1 node back. We don't have to even ask ourselves, what do we do if we get 2 or more? We just get 1 or none. So I ask if this return has a value. If it's not, then there is no quest. And if it is, I ask the node, the quest descriptor, for its property descriptor that describes the property name, and ask it to get the value on this node. And I already know it will be a string. So there is no cast involved here. I can skip on this cast, and of course it can't go wrong. Of course, yeah. The same thing with the procedure where we see the enums in action, of which I'm really proud. It's sort of the same. The input is the same. The fetching of the names is kind of easier. There is no literal string involved here. I have literal strings involved on that side. Of course, one could skip that and transport these literal strings into some static file where I define some global constants that never change. That is just good code programming practice, and everybody would do that. But I already know it will be a string. I can skip on the cast. I don't have to do that. Same with the nights. It's a lot easier to read. Here we iterate over the outgoing relationships of the type users. Here we just ask the night descriptor to get the used item on this node. Fetch it, collect it. The check whether the night is already using is the same. And here we have this switch where we can actually use an enum value. We don't use these literal strings anymore. We actually have the enum value, because this get value on, that's the property item kind, and it knows that the database uses a string, and it is supposed to yield an item kind. So it does the casting and the conversion already automatically. The same thing here. The relationship, creating the relationship is much easier to read. I tell it everything it needs to know, and it will do the same stuff as it does here. So this is, I think, easier to read, and I do not have to worry about the exceptions so far. But not having to worry about exceptions, of course, is slightly wrong. Everything that the descriptors do is, of course, exactly the same as I could do manually or traditionally. And everything that can go wrong in the old case can also go wrong with the descriptors. I could, of course, write the descriptors so that all the usual checking with all the tedious exceptions happens under the hood. But that would be a lot of ifs and buts and checkings, and that would slow it down. Instead, what we do is I assume that my schema that I defined with my descriptor classes is valid. I don't check it. What I do have is a validation procedure that does all the checking once. So if I remember to call the validation procedure and it passes, then I have the absolute guarantee that all the information or all the implicit assumptions that I expressed in my descriptors will work. So if I state in my descriptors that there is a one-to-one relation from, I don't know, a knight to his lover or something, and the validation passes, I have the absolute guarantee that there will be a one-to-one relation and nothing but. So I cannot get this exception. So in that case, the validation is sort of like unit tests. Like if I know all my unit tests pass, can be pretty certain, if I wrote the unit test correctly, of course, that all the assumptions that I make, that I have in my mind, the schema that I have actually does apply, and I can just rely on that and skip on all the extra handling. And Elena will now show how the validation procedure actually works.
Yeah, so I'm going to share my screen again. So what we're going to do first now is to introduce some more problems into the database. We already introduced one problem, if you remember correctly, by introducing the queen node, because that's already a wrong node, which is on the is involved in relationship. But I want to just introduce more so that the database has more, the validation has more to do. So what I'm just going to do is I'm going to match on the knight Sir Percival and on the Excalibur item. And I want to create the relationship Percival uses Excalibur. And if you paid attention correctly now, you know that there's stuff missing here. So the uses descriptor requires a since property. So I'm just not going to put it here. But also Excalibur is already being used by Sir Percival, Sir Lancelot. So then we have two people using Excalibur, which also doesn't work by the item descriptor, because the item descriptor says that there can be only one user for this item. So I'm just quickly going to send that. Of course, the database doesn't know anything better and does that. And also I wanted to introduce some type and enum errors. So I'm just going to use the item kite shield and just set its name to 42. Just random double long, which is not a string. So the item descriptor, as you saw, requires the name to be a string property. And I put the type of this item to be foobar, which is not one of the enums that we provided for the descriptors. Okay, so send that as well. And now I'm asking, what is wrong with my database? And as Jens already hinted at, so this is the very easy validate method that I could just run on my database. And let's see what it returns. It gives us a report out what kind of problems there are. So in our case, there are 6 problems. And for every kind of problem there is with some node or with some relationship, we also provide the Cypher query, which you can use in order to have a further look at this node or relationship. Maybe that doesn't help here. You can have a further look. So we have the node which failed the item descriptor test. So, and we see here there's the type problem, there's an invalid enum value, and there's a name problem. It's a type error, so it was expected to have a string, but it's a long. Okay, we all know where that came from, right? That's the kite shield, apparently. Okay, here we have another problem with the item descriptor. We have faulty relations, and you see this is a different item, a different node, has a different element ID. So failed to find expected relation. So the uses descriptor, which is incoming into this item that is faulty, has 2 relationships and not just 0 to 1, which it was described as. Then we have a node that failed the knight descriptor. because it has a faulty relation. Failed is the is involved in descriptor has 2 outgoing relationships, right? We have that was Sir Gawain, who's involved in the quest and also in the queen. So here's a problem, and we have 2 problems with the relationship descriptors. We have the is involved in edge, edge, which doesn't end in a quest. Okay, we know where that comes from, right? We had Sir Gawain is involved in the queen and not in the quest. Okay, another problem here, and we have the users descriptor, which failed our users relation, where we didn't provide a since property. And with that, you can see what your problems are and should resolve those before using your procedures to be sure that this all works out what you wanted to. And with that, I'm going to hand over to Jens again to sum this all up.
Let me share again. So you saw these basic ideas, and what we actually have. I want to go into the goals and pros and cons. And the non-framework code, as you saw, is deceptively simple. I just wrote very basic statements there. Most of what is slightly more complicated, that has to fit a certain schema, you can just copy paste from someplace else, because this init properties and labels node that has to happen in every constructor is the same in all derivations from the node descriptor. So that is easy to set up. All of the complexity is hidden in the framework, so it can simply ignore that stuff. Thing is, of course, the testing of that framework, especially because it relies so much on reflection and meta programming techniques, that testing has to be extra paranoid, because any small edge case is just really hard to debug. And the testing for this project is extra paranoid. I think the tests run for 5 minutes or something. It takes a long time, and I really try to test absolutely everything. The benefit we have is that similar things are absolutely guaranteed to always work the same way. And I'm a great fan of that, especially when you're working on old code, and especially on projects that run over a long time, and especially on projects that run over a long time with more than one author. Of course, 10 years ago, I made this commitment to myself. If I have this problem again, I will always use this schema, and I will deal with the similar problem in 2 years in the same way. I might have stuck to it, I might not have. In 2 years, I probably forgot how I did it in the other time. I might remember to check the other place, I might not remember. Maybe the language version increased, and maybe there's some nifty new technique that I really want to use, so I use this one, and it looks slightly different from the other one. I might have remembered to write all the usual unit tests. I might have been in a hurry. Maybe something had to be really fast. Maybe I fudged a little. Maybe I did write the unit tests, but maybe I did something slightly different. And then 2 years later, I get some edge case and it fails in one case, and the other one, which I think is exactly the same, and it works there. And I have to debug the whole thing. But employing this framework, because all the descriptors, there's really not much logic in there. They all use the same stuff, and I am forced to use all the same stuff if I decide to use them at all. So I'm always a big fan of similar things working the same way, no matter when I wrote them or no matter who wrote them. And by devising this framework, of course, you need the luxury of time to actually devise such a framework. It really forces you to think things through. Like, it really forces you to think about your use cases, to handle them properly, and to write elegant and simple functions that you can use like Legos to build something more complex. And of course, in the first draft for any such framework, well, I might not say for everybody, but I guess for everybody, the first draft is always crap. Like, you try something out, and in the end, you realize it's getting too complicated, or it's not actually what I quite need. So you have to do a second draft and a third draft, and maybe you don't have that time. I did have the time in this case. So this is the second draft, and the first one was way too complicated. And I like this, being forced to think about problems and being forced or having the opportunity to devise simple and elegant solutions. Because I think if the code looks simple and is elegant, then it will be stable. I have no proof of that, but I think everybody has this intuition that if a code looks ugly, it's probably going to fail, or at least it's going to fail in some weird way, and debugging that is no fun at all. So having a simple and elegant framework, there's a lot of value to that, but it's of course hard to do. And there are risks involved in that. I want to link to this article by Joel Spolsky. It's really old, 2002, and he's talking about how all abstractions leak. And what he means by that is we have some abstraction framework that is brilliant, like TCP/IP protocol. That's his example. I compare TCP/IP protocol to pushing the bits and bytes on some socket array. That's what you had to do before you had TCP/IP. Of course, nobody wants to do that. We want to use the nice abstraction. It's so much easier to use, but at some point, some weird edge case is going to happen, like way down, like several layers below, and you're faced with that. And that's what he means with these leaking abstractions. And that's, of course, always a problem with this multi-layer architecture, and especially a problem with like a new framework here that hasn't been tested for 10 years or something. And to put the same point more succinctly is this comic that I really like that sort of sums it up, how it works in practice. What happens if you introduce new layers that you think help you, but in the long run carry a lot of risks? So the descriptors in a nutshell, what we have is we have type-safe accessor methods. We know a property returns a number or a string or an array, and we know what array it is. We can even introduce these enum values, which the Neo4j database doesn't support, and of course can't support, because how could it possibly know what kind of custom enum you just wrote? We can add cardinalities to relations that will be enforced, or at least validated. We can assume that they are correct. Especially the 0 to 1 and the 1 to x relation gives me the luxury to write something like give me the neighbor. I don't have to iterate over stuff. I just state give me the neighbor and I get the neighbor node. We have these enum properties that hide the fact that the database actually uses some other type. I haven't shown this, but I also included a numeric property, and that numeric property works with number. And the numeric property doesn't care if the database has a double or a long, it can work with both. So I can simply ignore that particular problem if it's a double or a long. In some cases, it makes absolutely no difference, but maybe somebody forgot to type this 0.0 and I didn't do the validation, so that could be a problem. I have the validation user-defined procedures. Of course, it cannot enforce anything. Only Neo4j can enforce something like the constraints. The database will simply refuse to do that. Whatever I write in my descriptors, I can simply ignore it and tell the database to create relations, to delete properties, to change the types, and do whatever I want. The descriptors are not going to save me. But if I do call the validation, I know exactly what's wrong. A benefit for the validation is also, you've seen the string. The string array sort of formatted, I hope in a sort of nice way. What it actually returns is a DTO object. And that DTO object has a toString method or a print method. And that's what you saw in the browser. So if you use the descriptors with a proper UI, you can call the validation, get a JSON object, and then have an actual JSON object rather than a string that is formatted in what I think looked nice. So you can use that to display all the errors in a proper UI if you care to write such a UI. To set it up, I think I convinced you that it's easy. You don't have to write a lot of code. And more importantly, you can simply copy paste code from this project that we saw with the knights and the quests. Simply copy paste it, adapt it to your needs, run the validation, and you see if it works. There are some things that I would like to include, but probably I don't have the time. Just a sort of list of what I want to do. Especially I want to draw attention to the last 4 because I would really like to implement this stuff. I would like to have this regex constraint. You could specify on a string property that any value must conform to a certain regular expression. So the validation would test that, and when you ask for the value, you're absolutely guaranteed that the string does conform to a certain regular expression. And of course, regular expressions can do absolutely everything, so you can encode a lot of constraints by that. I would also like, as sort of generalization of the enum property, to specify properties whose value is an object. And the only thing that it needs is that object must be JSON serializable. So you tell a property on a node, your value is this object. And under the hood, the descriptors would deserialize it, write the string in the database, and if you ask for it, read the string, serialize the object, and you get the full object. And that, of course, can be any object you like. The database doesn't have to know about this. I think it would also be possible to auto-generate pretty much everything. Like every descriptor looks pretty much the same. I have to supply some names, I have to supply some basic information, but the actual code that you need to write is, as I said, mostly copy-paste, but that could of course be automated from some config file, and I'm not sure how to auto-generate Java code, but I'm sure there are frameworks to do that. I would also like to have wrapper classes. I think what is confusing for many people is the turnaround that is involved in reflection. Like usually you have an object and you ask the object for its name, like object get name. What we have here is we have the name property and we ask it to get the value on the object. And that's sort of turning it around, and that confuses people, and it's not that easy to read. So I'd like to have some wrapper classes. They would derive directly from node, take an argument, the node as an argument, and it's not a mapper. A mapper would copy the values from the database into your high-level object in Java. It's simply a wrapper because the node underlying it already has all the information. So I don't have the problem of synchronizing my object with the underlying object. I'm still working on the node, but I have all the luxury of having extra named properties and all the functions that the descriptors provide on this object. So that would be obvious further developments that I probably don't have the time for, but I think anybody can complete that. And that's us done. Probably too long, but that was our talk.
Cool.
Thank you for listening.
Great. Thank you very much, Elena. Thank you very much, Jens. A great overview, a great intro to user-defined procedure. And I think it's really clear to me now that they have strong advantages and strong reasons to be existing. And just one thing before there were 2 questions I'd like to read out. Because it's when you showcase the how the validation works and all that, it's really cool. But also in parameterizing the individual relationships, you like you said, Jens, you forget what was it called again? What is this? Is it involved in? Was it involved with? Was it go quest off, quest in? They can be so similar, and you don't remember anymore. Even if it's a small data set, it gets confusing. But imagine, like you said in the beginning, like millions of nodes, maybe even more, billions of nodes and relationships. Like, okay, I mean, I don't know how many labels for my relationships for my nodes. I don't remember. It's too much. So it's really a really strong argument there. I just, like I said, I wanted to read out 2 quick questions before we close for today. Is like one was from Paritosh. Good evening. Exciting, eagerly looking on parameterizing and user-defined procedure tips. So I don't know, do you have something for like people that now watch this and then wanted to get going? What would be like a good way to start, or what would be some good reference? You put some there, but some tips, maybe something to avoid, something to watch out for. I don't know. You are you've written so many probably over the past. So something, could you maybe give one or two that are good for beginners or even for experienced users?
Yeah, of course. So first of all, well, you just have to get into it. So you just have to get started at some point. And if you write a user-defined procedure or function, I think it's quite a lot of fun to just give it a node and then to iterate from one node to the other. And it's very interesting to start this journey. It was for me at least. So the problems that I faced at the beginning were really the problems of does this property actually exist on all the node that I come by? Because well, if you test your procedure on the database and it doesn't exist, then you get a failure. Then you have to go back to your code, debug it, clean and build again, deploy the plugin again. So it's a very tedious process. So my first advice would be do test-driven development, whatever you do on procedures, because you don't want to be busy with building, copy and pasting, restarting database, seeing an error and doing all that again, because that's very, very tedious. So write tests before you do anything, unit tests. And then, yeah, so as we basically pointed out with the descriptor framework, you can test it out, or at least write some kind of classes that put all your literals in there and create methods so that you don't forget to create the properties, and that you kind of at least read the properties from the nodes and relationships without needing to provide literals over and over again. And maybe do some at least some checking if you don't want to use the descriptors, whether this property exists, so that you don't have all these exceptions popping up all the time in the Neo4j browser.
Cool. Jens, anything you wanted to add?
No, that's basically what I would say.
Cool. Great. And then the other comment or question comes from Peter. He says, it sounds like this would be a good solution for an application that needs to repetitively merge complex graphs over time. Do you see anything to watch out for in this use case? Or is there something you would say could be a good user-defined procedure use case in itself?
Yeah, well, of course, yes. This is a good user-defined procedure use case. The question that you have to ask yourself is whether there's a specific business logic behind it or not. So if you want to write a user-defined procedure that does the merging, irrespective of what kind of nodes are getting merged together, then you shouldn't use anything like the descriptors. You should use like general code like APOC or GDS does, right? But if you know that there's going to be, like in our example, quest nodes and night nodes and item nodes, and after the merging you want to adhere to the original schema again, and you only want to create relationships or keep relationships that adhere to the schema, then yes, of course, that's a perfect use case for the descriptors, I think.
Yeah.
I actually wrote something probably similar. We had the idea of having a large graph, and we want to pull out a subgraph from that, edit it, and then merge it back. We wanted the option to edit it, try something out, and then we wanted to give the user the option of like, nah, this is crap, just forget everything. Or the option, okay, this is good, I want this merged back. So you basically had the base graph, and then you had a subsection of that which had slight changes in it. And how do you merge these two? So it's basically sort of like a Git merge, the same problem apply. You have these merge conflicts and you need to solve them. And I think we used the descriptors for that. And you could also, of course, then verify if the procedure that you wrote, you can test it on random graphs and then verify, let it run the validation to see if you forgot anything. So it would be a good case, especially for large changes. I mean, you could, in theory, call the validation if you just do some small change, but that's probably a waste of time if you have a large database. But if you do some major merging of large databases, then that is an obvious point where you could use the extra validation just to be sure that you haven't forgotten anything.
Cool. Yeah, thank you very much. Again, thank you very much, Elena and Jens, for presenting today, for the demo, for obviously always appreciated and nice to see some code, some hands-on, but as well as going over through the slides. So that was really great. I think it's a you said in the beginning a little bit niche, but I think it's very special and very powerful use case. So how to use and how to work with Neo4j as a graph database. So I hope you like that. I'm sorry we ran a little bit over, but I think it was interesting and valuable. Thank you all for watching. And if you have any further questions, any further remarks on user-defined procedures, the contact details from both Elena and Jens are in the video description on YouTube, so you can reach out to them there. Obviously, you can bring your questions to the Neo4j community forums or Discord server. There is also an active community there, and you can discuss things there. Otherwise, yeah, thank you all for watching. Thank you for taking the time today. And I think, yeah, next session is going to be on the 5th of December. Believe it or not, it's going to be already December, 2 weeks time, going meta episode 23, where I'll talk to Jesus about our monthly series. And on the 6th, a day later, I'll do a special stream on powering advanced Streamlit chatbots with GenAI. So wrapping up the year. This is not the last one, but going into the close to the end of the year. So we'll have that as another Neo4j live on the 6th of December. Yeah, and with that, thank you all for watching. Stay safe. See you soon, and have a good rest of your day, or whatever else is waiting for you. Thank you, Elena and Jens.
Again. Yeah, thanks for having us. Bye.
Thank you.